Let's practice with Planck's constant. So looking at number 1, we have a photon with an energy of 16 electron volts moving through outer space. Calculate the energy of this photon in joules. So the first thing that we want to do is we want to go to our reference table and we want to look at the relationship between electron volts and joules. And we know that 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. So, in order to go through and solve this, we started with what we were given, so 16 electron volts, and we put that over 1. We want to get rid of electron volts, so electron volts goes on the bottom, and we want to end up with joules. All you do is literally copy exactly what you see from your reference table. So 1.6 times 10 to the negative 19 joules is equal to 1 electron volt. Go through and solve. Remember, this becomes basically like one big long fraction where you're multiplying the top and multiplying the bottom. So we end up with 2.56 times 10 to the negative 18 joules. When you go through, electron volts cancel because it's on the top and the bottom. Looking at letter B, calculate the photon's frequency and wavelength. So if we want to calculate the frequency is equal to, or to solve for it rather, we use E equals HF. E is the energy that we just solved for, so 2.56 times 10 to the negative 18 joules is equal to Planck's constant, 6.63 times 10 to the negative 34 joule seconds, multiplied by F. Solving for F, make sure that you use parentheses, always, always, always. You should end up with 3.8 times 10 to the 15 hertz. This question, however, also asks you for wavelength, and for this, we're going to use E equals hc over wavelength. E, again, is our 2.56, 56 times 10 to the negative 18 joules. That's equal to Planck's constant, 6.63 times 10 to the negative 34 joule seconds, multiplied by 3 times 10 to the 8 meters per second, all over wavelength. When in doubt, put your left side over 1, cross multiply, divide, do all the math, and we should end up with, let's see, 10 to the negative 34, 3, 10 to the 8, 6, 10. All right, so hopefully you ended up with the same answer as me, 7.77 times 10 to the negative 8 meters. We were solving for wavelength. All right. Letter C, what part of the electromagnetic spectrum does this photon belong to? Well, we can look at either wavelength or frequency. If we look at frequency, frequency is 10 to the 15 hertz. That's this piece right here, 10 to the 15 hertz. So we go back to our reference table. We look at our electromagnetic spectrum. Let's get rid of all of this here so we can see what we got going on. All right. So 10 to the 15 hertz, you look at frequency for hertz, 10 to the 15, and we go all the way up, and that hits ultraviolet. So our answer should be ultraviolet. For number 2, a photon with a wavelength of 5.45 times 10 to the negative 7 meters is traveling through a vacuum. Calculate the frequency of this photon. Well, here we are looking for wavelength, and we're looking for frequency, and they give us wavelength. So what we can do is we can go through And if we look at our equation, the equation for the modern physics, when you look here, you are given meters, so you're given wavelength, so you need this part of your equation. We know that we're looking for frequency, so we're using this part of your equation, which means that we don't need the energy. All we need is the second and the third term. And when we look at this, let's erase this so that you can see, when you look at this equation right here, you should notice that on the left and right side, you have h in both terms. And if you have h, the same variable on both sides, you should know from math that you're able to get rid of it, which means that your formula should just become F equals C over wavelength. So now what we can do is we can go back to our notes, back to our problem, and that's the formula that we're going to use. So F is equal to C divided by wavelength. C we know was 3 times 10 to the 8 meters per second. Wavelength they give us 5.45 times 10 to the negative 7 meters. Make sure when you're plugging it in your calculator, you're using parentheses. And you should solve, hopefully correctly, and end up with 5.5 times 10 to the 14 hertz. They then ask you, what color of light does this photon represent? Well, we have 5.5. So if we look at our reference table, and we look at the visible light spectrum here, 5.5 falls between 5.2 and 6.1. So 5.5 should be green. So we know that our answer here should be green. Letter C, calculate the photon's energy in joules and in electron volts. So here, we're going to use the formula E equals HF. We're looking for energy, which is E. H is our constant, Planck's constant, 6.63 times 10 to the negative 34 joule seconds. F is what we just solved for, 5.5 times 10 to the 14 hertz. And solving in our equation always uses joules. So we should end up with 3.65 times 10 to the negative 19 joules. They ask us to take this and convert it to electron volts as well. So we start out with what we have, which is our answer of 3.65 times 10 to the negative 19 joules. We always put that over 1. You want to get rid of joules, so joules goes on the bottom. Electron volts is what we're looking for. Oh. And as you go through, you just copy exactly what you see. So 1 electron volt is equal to 1.6 times 10 to the negative 19 joules. Joules will cancel. This becomes one big long fraction. Solving for this, you should end up with 2.28 electron volts. Lastly, number 3, a spacecraft collides with a 40-kilogram meteorite. So they're telling us that we have 40 kilograms. Converting it directly into energy. You're going directly from mass straight into energy. Determine the amount of energy released in joules. Well, if you're going from mass right into energy, that is E equals mc squared. E is your energy. Mass is 40 kilograms. Multiplied by 3 times 10 to the 8 meters per second squared. Solving this, hopefully you ended up with 3.6 times 10 to the 18 joules.